understanding for your consumption is energy, voltage, and charge. Let's see how they are connected, okay? Let's see how they are connected, right? Good. Energy, voltage, and charge. Look at it here. Energy, voltage, and charge. When a charge moves, a potential difference, electrical work is done, and the energy is transferred. I take it again. When a charge moves through a potential difference, electrical work is done, and the energy is transferred. Can you see they are connected? Can you see how they are connected? Potential difference. Look at the PD. When a charge moves through a potential difference, that's number one. Electrical work is done. That's number two. Energy, in the process of electrical work being done, energy is transferred. Energy is transferred. That's concept number three. Good. The potential difference can be calculated using the equation given below. So now the charge moves through a potential difference. Okay? Electrical work is done. Electrical work is done. I repeat, electrical work is done. Energy is also transferred. So we want to know the value of the potential difference in this aspect. We want to know the value of this potential difference. What is the value of this potential difference? For instance, we know the amount of energy that has been transferred, and then we know the value of charge in a system. All right? For us to do this, there is this formula here. This formula will help us to achieve that purpose. All right? Where V stands for the potential difference, E stands for energy, look at it, energy, and then Q stands for charge measured in coulombs. All right. Now, there is something we need to understand. This is when potential energy is measured in volts. It means that potential energy has an SI unit known as what? Volts. Energy E has an SI unit known as what? Joules. Right? And then charge Q is measured in an SI unit known as coulombs. C. I repeat. The unit of potential difference, look at it. The unit of potential difference, PD, represented by the letter V, is volts. That is V. Energy is measured in joules. Take note. Charge, quantity of charge, is measured in coulombs, represented by letter C. Take note. Therefore, it means that 1 volt is the potential difference when 1 coulomb of charge transfers 1 joule of energy. Yes. All right? Let's see this clearly. It means this simply means, all right, for clarity purpose, I want to make sure we understand what this means. What this means is that when 1 volt of the potential difference, okay, is work done in transferring charge through potential difference, okay, certain amount of energy or certain amount of charge is also transferred as 1 joule of energy. That is it. 1 volt is the potential difference. Listen, 1 volt is the potential difference when 1 coulomb of charge transfers 1 joule of energy. So we must understand that. All right? Okay, having said that, there is this simple question that is expected of us to solve. Look at this question. We have been expected, or we are asked to solve this question and estimate the value of potential difference in this section, in this question. Okay? We are asked to find the potential difference. So how do we do that? We are going to do that by simply applying this formula. We are going to find V because we have E and we have Q, right? The question is, what is V potential difference, that's referring to V, between 2 points if 2C. 2C means 2 columns of charge. All right? 2C, I repeat, 2C, this 2C you look at simply means 2 columns of charge. Shifts 4 joules. All right? That is the amount of work done is 4 joules. But what makes this work to be done is 2 columns of charge. So we are asked, they want us to find out the value of potential difference between these 2 points. Very simple. We are going to apply this formula. All right, take notes. In our next slide, you will see how this formula is applied. Okay, so we are going to check between this slide and the next slide so that we solve. So in the next slide, we are going to take time to solve this. We begin by writing our solution, and we're going to solve this boldly. All right, we are going to solve this boldly. Our solution, very, very important. So by the time we write out our solution, another thing we are going to do is to make sure we bring out, extract the data contained in the equation, and that will help us a lot. Let's do something reasonable. This line, I don't like it, let me remove it, and then do something beautiful here. All right, let me see how this goes. Okay, so we use this. Now, potential difference PD, take notes. Okay, PD is what we are looking for, and it is represented by letter what? We are representing potential difference by letter V, all right? Okay, and it's giving us what? Potential difference is unknown, so question mark. We don't know the value of the potential difference, so it is unknown. We need to find out what the value is all about. That's why it is unknown, all right? Then, but we are giving energy. We are giving charge. That's the energy, okay? We are giving charge, and we are giving also energy. The energy in that is what? 2, is it 2 or 4 joules? Okay, that's 4 joules. The amount of energy given is 4 joules. Then Q, we know the value of Q is given. Q is giving us 2C, that is 2 columns of charge. Good, that's 2 columns of charge, 2C. So what do we do? Very simple. We recall again our formula. Let's not forget that our formula for solving this is very simple. We need to write it down because we want this to be something captivating, something interesting, something that one can look at, copy as notes, something that one finds pleasure learning. So our formula is what we are writing out, okay? Our formula is going to be stated as follows, okay? I'm trying to put something down for us to understand. Our formula is very simple. We are going to use V, which is the potential difference we are looking for, equal to, all right, E over Q, right? The energy, okay, in the system, all over Q, that is the charge. All right, okay, good, we've gotten the formula. So the next thing we are going to do is to substitute accordingly. We substitute accordingly. The energy in the system is 4 joules. We write 4 for now and leave the units. All right, then the amount of charge in the system is just 2. That is 2, right? Good. So 4 divided by 2 is going to give us 2. All right, so we have arrived at the answer, just 2. Therefore, right, potential difference V is equal to potential difference V. Let us correct something quickly. This is not supposed to be here. So potential difference of V is equal to 2 volts. Is equal to 2 volts because potential difference is measured in volts, right? is equal to 2 volts. You write it in such a way to refer to it, and no distant time is equal to 2 volts. And that's how it's done. Very simple. So this is our answer. So we have solved that. Very simple. Okay? We have now found the value of the potential difference in that question as asked, as we are expected to find. All right. At this point, I want you to subscribe. All right? Subscribe. If you have indeed found pleasure in this learning experience, it is time for you to consider subscribing. Consider to give us some thumbs up, some likes, share to your friends, to your networks, to your students. Who knows, you might be helping somebody somewhere. Also, don't forget to turn on the bell button for post notification each time something like this is uploaded for your learning pleasure. All right, it's been Dr. Kingsley. With this, we have come to the end of this topic. All right, thank you so much for watching. See you in my next video. I am going to be linking another video somewhere here or somewhere there. My video will always come as a